So what's EK or KE, kinetic energy, and what's GPE? How are they related? How are they different? What does it all mean? Well, GPE, kinetic energy. The transfer is happening instantaneously. When something is at a height, it has gravitational potential energy because it's subject to the effect of gravity and it has the potential to fall, right? And as it falls, it gains kinetic energy because kinetic energy is just movement. Okay, it's the movement energy. That's kind of what we associate it with. That's what we call it. So there's always this constant transfer between gravitational potential energy and kinetic energy. And we can actually say that the kinetic energy at the bottom of a fall is the same as the gravitational potential energy at the top of the fall, provided no energy is lost to the environment. Now, in a perfect world, in a vacuum, that would be the case, but we're not really dealing with vacuums, okay? We're surrounded by particles and things are lost. Energy is transferred to different stores, like thermal, like sound, lots of different stores. So in reality, that perfect kind of transfer from GPE to EK doesn't really happen. But in this example, in this tutorial video that I'm just going to play in a moment, I will talk to you about both energy types and how we can actually apply these two equations to do some really nice, elegant mathematics. I hope you enjoy it.
Okay, so let's use our knowledge of energy, GPE, and kinetic energy to answer this question. So the question says that a ball with a mass of 300 grams, so let's write down everything we have, 300 grams, is dropped from a cliff from a height of 18 meters. So my height is 18 meters, cool. And it says that the ball travels at 1.3 meters per second. So my velocity is going to equal 1.3 meters per second. Cool. And it says it wants us to find the ball's GPE, gravitational potential energy, as it's let go. So the moment it's let go, which is where height is going to be at its maximum. And its kinetic energy, that's what EK means, okay, is EK just before it hits the ground, okay? So if this is my cliff here, okay, let's try that again. If this is my cliff here, and this is me, okay, and I've dropped my ball, okay, and my height is going to be 18 meters, right? We need to find the GPE at this point here, okay, just as I let it go, and if this is the ground, then so at this point here. So we want GPE here, and we want EK, or kinetic energy. You might see it written like this, same thing, at this point just before it hits the ground, okay? So let's start with GPE. What do we know about GPE? Well, we know the equation, okay, and we know that GPE is equal to mgh, okay, mass times gravity times height. Okay, now the first thing that we need to do is convert our mass from grams to kilograms because we always work in standardized units. So since there's 1,000 grams in a kilogram, we can divide by 1,000 to get to kilograms. So we know that 300 grams converts to 0.3 kilograms. Cool, good stuff. And then we just substitute our numbers into our equation over here, right? We just sub in, okay? Velocity, we'll deal with that in a moment when we calculate kinetic energy. So we know that GPE is going to equal mass, which is 0.3 kilos, times gravity, which is 9.8 meters per second squared. That's the gravitational constant on Earth, multiplied by the height, which is 18 meters. Okay, and if we plug that into our calculator, I'm actually going to do it with you guys. 0.3 times 9.8 times 18, we get 52.92 joules. Okay, GPE is a form of energy, and every form of energy is measured in joules. Okay, so what's nice is we can actually answer this second part here, the kinetic energy is just before it hits the ground, without even doing any of the calculations, because the kinetic energy is going to be this. Okay, if all of the GPE is transferred to kinetic energy, then we can say that because this transfer has happened completely from one form of energy to another, that the two energies will be the same, okay? Because there's this transfer happening from gravitational potential energy to kinetic energy. As one goes up, the other one goes down, okay? When GPE is at its maximum here, kinetic energy is at its minimum, and when kinetic energy is at its maximum here, GPE is at its minimum. So we can say that the two are sort of interchangeable, okay? Unfortunately, in real life, this is not really how it works, okay? And we know that this is not how it works because energy is actually transferred to our environment, right? Energy is transferred, and you'll have seen that in the other video on stores and transfers, to other types of energy, okay? To sound energy, to thermal energy, right? So energy is wasted. So in reality, these two are not actually interchangeable, but for the purposes of your GCSE, if you have a question like this, you can assume that the kinetic energy and the GPE are completely transferred between one another and are therefore the same in this kind of situation. Okay, but for the sake of completeness, I will calculate the kinetic energy from this question, which would be half times mass, which is 0.3, times velocity squared, which is 1.3 squared. Okay, because the equation for kinetic energy is half mv squared. Okay, and if I plug that into my calculator, I get what do I get? I get 0.25 0.2535 joules. Okay, so certainly not the same. Okay, but that's because energy is wasted. Okay, so just make sure that you have that distinction. In your GCSE, you need to know that these two are completely transferable, okay, assuming that no energy is wasted to the environment, okay, but energy is actually wasted to the environment, which is why these two values are different.
Okay, so hopefully that tutorial helped you understand what's going on with GPE and EK. I love these equations, especially if you want a challenge. Rearrange EK for V, make V the subject. That comes up in higher papers sometimes. Great 4 or 5 mark question. But in the meantime, guys, please like and subscribe. As always, it really helps us get more quantum content to you guys, and we love making content for you, okay? It's just such a pleasure to get this information out to you guys. But yeah, I'll see you in the next video. Bye!